Let's look at an example about the variable force in one dimension. We have in this problem a variable force F that acts on an object moving along the x-axis. If the force has only an x component and the graph shows how it varies with x, the question is, what is the work done by this force as the object moves from position x 10 meters to position x 50 meters? Remember, for a variable force in one dimension, the work is going to be simply the area under the force versus position graph. So we'll just go through the graph from 10 meters to 50 meters and see what the area enclosed by the graph is. We start here with the rectangle. From 10 to 30 meters, we recognize that the force stays at 100 newtons. I'll mark this area as A1. And I can calculate it, since the area of a rectangle will be the base 30 minus 10 multiplied by the height 100 newtons. So I can see that the work here during this change from 10 to 30 meters will be plus 2000 joules. Plus means that the force here is contributing positively to the kinetic energy of the object. The next area here is a tiny triangle from 30 to 40, where the force decreases from 100 to 0 newtons. I will use the geometrical formula for an area of a triangle, so I'll have 1/2 the base. The base in this case will be the difference between 40 and 30, and the height will be 100 newtons, so here the area comes out to plus 500 joules. And then the last step, I have to actually subtract one area, which is still considered under the graph, even though it appears below the x-axis. Under the graph means it is enclosed between the graph and the x-axis. It appears below, so it will be counted as negative. It's a triangle, once again, so I'll have 1/2 the base of that triangle, 50 minus 40 meters, times the height, and notice how here I'm going to place minus 100 newtons for the height, to distinguish from the other triangle, which was above x-axis. You could have easily seen that the triangles A2 and A3 will have similar areas that will just appear with different signs. So if you recognize that the areas cancel out, you don't have to write it down. But here I have it, and so the area of the triangle A3 is minus 500 joules. So finally I can say the work of the force as the object moves from 10 meters to 50 meters is going to be equal to the total area. In this case will be 2000 plus 500 minus 500 for an answer of a total work of 2000 joules.